Hello, I'm just going to walk you through a little bit of this final worksheet on chemical reactions. A few things to note. So, the first step you're supposed to do is to classify each of the types of reactions. And if you forget how to classify a reaction, you can check on your reference tables, and you'll find on your reference tables on page 6 down towards the bottom, it's got your general templates for each of the 5 types of reactions. And even though they're listed in this order, I suggest that you start with number 5, the combustion reactions, so that you don't get confused. So look for things that start with hydrocarbons and oxygen and make CO2 and water. So for instance, I'm seeing one of those in number 7. So number 7 is combustion. And then it looks like we might have another one down here at number 12 is also combustion. Then you can look for your synthesis reactions. Keep in mind, synthesis, you're just adding 2 things together. So you've got multiple reactants in one product. For instance, number 5 is a synthesis. And for you, it's probably easier to just type this directly into the Google document that you got. The third type of reaction is decomposition, which is the opposite of that. You've got one reactant, multiple products. A good example of that is number 6. And then we've got our single replacement and then our double replacement reactions. So single replacement, you have one reactant on that's by itself on each side of the equation, and then you have a compound, and so the one of the elements switches out with another one. So like, for example, number 1 is a single replacement, number 2 is a single replacement. Then you have number 3 is a double replacement where everything just switches places. So 3 is a double replacement. Let's look for a couple more examples here. Number 8 is a double replacement. And then let me pick one more that I want to show you. Number, which one is it? Number 19 is a double replacement. That looks like a good one to look at. The next thing you're supposed to do is balance the equations. Number 1 happens to already be balanced. For number 2, you'll notice there's 1 aluminum on the left and 2 on the right. So we put a 2 out in front of the aluminum. There's 2 irons on the left, 1 on the right. So you'd put a 2 right there. That one's pretty straightforward. We can also look at some more complicated ones like number 6. You've got 1 sodium on the left, 2 sodiums on the right. So you put a 2 right there. We then have 2 hydrogens on the left, 2 hydrogens on the right, 2 carbons on the left. 1 plus 1 is 2 carbons on the right. And then we have 6 oxygens on the left, and then we've got 3 plus 1 plus 2, which is 6. So that equation is now balanced just by putting a 2 out in front. And then another one that could be a little bit trickier to balance would be something like number 19. You've got 2 aluminums on the left, 1 on the right, so you put a 2. You have 3 sulfates on the left, and so you put a 3 on the right. And then that's 3 bariums, so you put a 3 on the left, and that's 6 chlorines, 6 chlorines. That one actually balances out pretty well. Combustion ones can also be tricky, so I'll go back and show you number 7. You have 9 carbons on the left, so I'll put a 9 right there. You've got 20 hydrogens on the left, so 10 times 2 is 20. And for oxygens, on the left, we've got 2 on the right. We have 18 plus 10, which is 28. And so 14 oxygens goes on there. Now, for the third step, we only need to do the third step for our single and double replacement reactions, so you'll not do that for synthesis. That's not applicable. Not applicable, not applicable, and not applicable. So for the single replacement reactions, in order for it to happen, you need to check on page 7 of your activity series and see if the thing that's by itself on the reactant side is higher than the thing that's being replaced. So for instance, in number 1, we need to see if chlorine is higher on the activity series than the thing it replaces, which is bromine. And chlorine is higher than bromine. So since that is the case, yes, the reaction takes place. Number 2, we need to compare aluminum with iron. Aluminum is higher up than iron. So yes, the reaction happens. For double replacement reactions, however, you need to see if you form a precipitate. So you go back to your solubility rules, and precipitates are things that are insoluble. So we're looking for something that fits into this category. So we need to check to see if the things we produce, our products, any of them are insoluble. So we have silver chloride right here. We look, the second rule right here says all chlorides, bromides, and iodides are soluble except silver chloride, meaning silver chloride is insoluble. It's a precipitate. So we make a precipitate. So we'll say yes, a reaction happens. And then the last step, it says highlight the precipitate. And there's a little highlighting tool in Google Docs that you can use. In number 8, we look at our products. We have zinc iodide. So all chlorides, bromides, and iodides are soluble except silver, lead, and mercury. So that's soluble. That's not a precipitate. And then we have potassium nitrate. Well, all nitrates are soluble and all group 1 compounds, and potassiums in group 1 are soluble. So we don't have a precipitate. So no, we have no reaction. And then the last one to look at is number 19. It's a double replacement reaction. We check and look at things here. We've got our 2 products are aluminum chloride. Well, all chlorides are soluble except silver, lead, and mercury. So aluminum chloride is soluble. And then barium sulfate. Well, all sulfates are soluble except barium sulfate is insoluble. So that is a precipitate, which we will highlight. And so since we have a precipitate, yes, we have a chemical reaction. I hope that helps.